The only way to know if your software is reliable is to test it and find out. So how can we test a fallback API in a Mule application? Let's look at the fallback API pattern. So we're going to build a flow that provides normal service with backend 1 above on the right, and when backend 1 fails, the Mule flow needs to fall back to backend number 2. We're calling that the fallback backend. So this is a very simplified implementation of the fallback pattern. Let's go to Anypoint Studio and implement a fallback pattern test first. So here's my flow that does not implement the fallback pattern. This is a simple flow that simply depends on an API request to backend number 1. Let's look at this request. This goes to backend 1 HTTP request config. It's a post to the important resource path. All right. And we'll just check on a functional test for it. So this is, I've got 2 functional tests that make sure that the flow works under normal circumstances. Right. So we're going to run those. The first test, it creates a sample input, which has name and ID, an array of names and ID objects. And then it uses a flow reference to reach reliable flow 1. Right. That's this flow here, which is going to transform that input and post it to the API, get back a result. Right. So the very first test here uses a mock to simulate the results from flow 1, and it uses a spy to capture the input that we send to backend number 1. Right. So the spy is matching backend 1 HTTP request config, and it's storing whatever got sent to the API, and then in the execution section we retrieve that stored value, and then we can validate that it indeed was whatever we were supposed to send to flow 1. So we've got a functional test that makes sure we call the API properly, and we've got another functional test that makes sure that we capture the results out of that API properly as well. That one only needs a mock. And the mock is going to send a controlled value back. This is important in functional tests. We're going to bring back a controlled value that has the expected value back from backend 1, and then of course validates that value was received after the test is done executing. It's important when you build reliability tests to have tests of normal behavior to depend on while you're updating the code to have some kind of reliable behavior. So we're going to run the suite, and there's the functional test. And indeed, both of our functional tests are green. It's going to be key to keep these tests green as we build the new tests for the reliable behavior, in this case, the fallback pattern. So we want to create a fallback where if this API fails, if there's some kind of an outage, then the flow is going to fall back to fallback backend, which I've conveniently named fallback backend HTTP request config with a different host name. So we're going to implement that test first. So I've created a separate MUnit test called resilience tests. Here we go, and we're just going to start by building the MUnit test similar to the functional test. We're going to bring in a test scope. We always start with the flow reference that we need to invoke the flow we are testing. So there's reliable flow 1. All right. Great. And it's going to need a sample input. So what I'm going to do is go to my functional test and take the sample input that I've been using for my functional test, and we're going to copy and paste that into our new resilience test. There we go. So now we have a sample input and we have a reliable flow 1 output. Okay, so what we want to do is test what happens if the backend number 1 is down. So we need some way to simulate backend 1 being down. Well, luckily, I've already built this test with a invalid backend. right? So if we look at our flow, the backend 1 is using backend 1 as the host name, which doesn't exist. I can even make sure and put broken in here like that, and see what a normal failure looks like, right? I want to see what happens if I run this test with a real error, and then I can see what it would look like. So we're going to run this test immediately with no validations and just see what happens when it can't reach the backend 1. Oh, look at all those errors. Good stuff. All right, we can scroll in the logs and we can see that we got an exception, Java NIO channels unresolved exception. That's way down at the bottom of the stack trace. I usually like to scroll back up and see what the first error was. There's an IO exception, and that caused an HTTP connectivity while running test. HTTP post on resource backend 1 broken. Failed, couldn't resolve address. All right, so we're going to want to make an error like that happen in our test. Okay, so first I'm going to go back and repair my global element for backend 1, this one. We're going to put the host name back. And instead, we're going to make a mock that simulates that happening. So we're going to go add a mock when for backend 1. So we want post to /important resource backend 1. We're going to pick a processor and make it match the actual backend that we're reaching. So I usually like to match on config-ref, path, and method if I can make that work, which most of the time I can. And there's a few ways that we can simulate this error. I'm going to use HTTP connectivity, which is the error that we see here in the MUnit results, right there. However, it is not very realistic, and I want to show you why. This error has a cause, which has full information about what went wrong, and there's a whole lot we can do to try to simulate realistic errors. So if that's something you'd like to see is more realistic error simulation, please put a comment below, especially about which kinds of errors you're hoping to simulate. All right, we're going to just use a simple HTTP connectivity here. We're going to go to the then return section of the mock when, and we're going to add an error, HTTP connectivity, in the type ID. So now we're simulating the error, and if we rerun the test, we're still going to get a red error, and we'll see what our error looks like, and hopefully it's close enough to allow us to test our fallback pattern. I hate this test name. We are fixing that right away. It's the default test name. All right, let's see what we got, though. It says, here, there we are. Just drag this over. Here we are. All right, test execution exception error, HTTP connectivity while running test. Now, we don't get all the nice text in here, but it is the same error type, which is good enough for our test scenario. So when that error happens, what would we like the flow to do? Well, we want it to fall back to the fallback backend, right? So we're going to have to define one and test that that is indeed what gets the request. So I'm going to go borrow from my functional tests. I already have a functional test that can test if a backend returned a particular value and properly, right? I have a mock, and it produces an expected value that's only going to come from that one backend, and then I have an assertion here that allows me to check that that's indeed what came back. So we can do that in our resilience test as well. So we're going to go back to the resilience test, and first I'm going to start with the assertion. I like to work from the result backwards, right? So I'm going to put assert that here. And we're going to say that we assert that the payload.value field, which is going to come back from the back end, is We're going to use MUnit tools equal to, and I'm going to put result from backend 2, which we haven't created yet, but at least it gets us started building our test. So we want to somehow get this result from backend 2 to come out of this flow when backend 1 is down. So I've forced backend 1 to be down, and I've asserted that I get value is equal to expected from backend 2. So now I just need to make backend 2 give me back that value. Well, I don't have a backend 2 set up in here yet, right? However, I can create an HTTP request config. So I did that before. I opened this code. I created a second HTTP request config for backend 2, for the fallback backend HTTP request config. This is going to represent the fallback backend here on the diagram. So let's go ahead and mock that one. So here's how I'm going to do that in this resilient. So we're going to call this a fallback test. There we go. And I'm going to make another mock with a different request config, right? So I can just copy and paste the existing mock. There we go. And we're going to do a mock for backend 2 instead of backend 1. Now, what makes it backend 2 is this config ref in the mock's attributes that it's matching on. So we're going to change that to the fallback backend HTTP request config. And now it's simulating what happens when that one comes back. Well, when that one comes back, I do not want to have an error. I want to have the expected backend 2 output. So I'm going to get rid of this error that I copied from the first mock. And I'm going to go back to my payload, and I'm going to make it return application JSON media type. And we're going to give back a JSON value. There we go. Where the value is equal to expected from backend 2. So now I've got one backend that's going to fail with HTTP connectivity, and I've got another backend that's going to give me back the expected from backend 2 value, and then I'm going to validate that indeed I get the expected from backend 2 value that I'm hoping for, right? So far I've just built this unit test, and I have not updated my code yet to do the actual fallback. This is a practice we call test-driven development, where you make the test express exactly what you want the code to do before you build the code to do it, right? So we're going to run this test, and hopefully we're going to have an error that tells us what we're expecting. So when you build a test first, you kind of want to make the error that comes out, the failure message, match up with your expectations. That way you make sure that your test is designed properly, and you know it's it's really testing what you're intending it to test. So let's see what it does. Okay, we got a failure, but remember we haven't coded the fallback yet. Let's see what the failure says. HTTP connectivity while running test fallback test. Of course, it's still the flow is still erroring out with an HTTP connectivity, and that means it is definitely not giving me the expected value. So I think it's time to implement our fallback pattern and see if we can make the test pass. So what we're going to do is we are going to put a try in here. We're going to use a try scope and put the HTTP request in there, and we're going to create an on-error continue that checks for HTTP connectivity. And I'm going to turn off log exception, and we are going to have it simply make another HTTP request to there we go, backend 2. All right, here we go, and this one's got to do a post to /important resource, and let's see if that makes our test pass. Oh, we got a failure. Let's see what this failure says. Assertion error. Aha. Check that out. So this is a mismatch between what I have an error in my test. It's expecting result from backend 2, but it got expected from backend 2. So I'm going to have to pick one or the other to be my test. Let's go back to the functional test and see what I used. Apparently I used expected from backend 1. So really what the mistake was here is that my mock did not use the right expected value. Wait, so it got expected from backend 2. Aha. No, it was my validation. My assertion was checking the wrong thing. So we're going to change that to expected from backend 2 and run it again. And we have a green test. Now we had a red test, and we fixed the assertion, and now we have a green test. So there's a couple of ways we can make sure our test is actually working and worth its and providing the value we hope it's providing. So one thing we can do, we've already checked that the assertion needs to match the actual output. I guess what we could do is we could try breaking the code in a couple of ways to see if it actually is testing the right thing. So we're going to go to the Fallback API, and let's go ahead and just put a bad path on the Fallback API call, right? And if you can try to predict what the test is going to do if we change that, and which part of the test that affects, then you are getting something out of this process. So let's see, let's run that. I have now changed it to use a different path on the back end, important resource bad. So if someone comes in here and changes my Fallback API call, let's see what happens to my unit test. Someone is usually me a few months later while I'm working on my code. We got a failure, and it says HTTP connectivity error when running test fallback test. It posted to backend 2 important resource bad. So why did it try to actually post to the backend 2 instead of using my mock? Well, let's go look. Here's my mock that I had set up, and this mock only matches on path important-resource, not on important resource bad. Right, so that's why the mock didn't get used and we got an error. So the test is kind of serving its purpose, isn't it? So okay, I'm going to put this back, and we're going to save this test and get back to green. And here's where you always commit your code with a good comment and push it to your repo and let your CI process kick in. And we've now got a reliability test. Oh, and it's super important that we need to run the all the functional tests as well, because we have now modified this code, and we need to make sure that the original functional tests are still passing as well. So after the resilience test passes, there we are. We're going to run the entire test suite. All right, and we have green. So I hope this video helped you learn a little more about how to build reliable code in Mule. If you enjoyed this video and you want some more, please put a comment below that says what you'd like to see for Mule reliability patterns or testing patterns. Please give this video a like, and subscribe to our channel so that we can give you more content like this. And if you're really into MUnit, we have a workshop series at integration.quest. You can sign up and come work with me on MUnit testing, and I look forward to seeing you there. So thanks for watching. We'll see you next time.